You used electricity today, probably dozens of times before breakfast. You turned on a light, charged your phone, opened a refrigerator, used a computer, maybe made coffee, maybe watched a video. Electricity flows through almost every part of modern life. It powers cities, factories, hospitals, satellites, entire civilizations. And yet, there is something strange about it. For most of human history, electricity did not exist, at least not in any useful form. No light switches, no batteries, no power plants, no electrical grids, nothing. Which raises an interesting question. How did humans actually invent electricity? Because unlike fire, electricity was not something you could simply discover and start using. You cannot pick it up. You cannot see it directly. You cannot store it in a basket. And for thousands of years, it appeared only in brief and mysterious flashes. Lightning in the sky, static shocks, strange effects nobody could fully explain. Electricity was everywhere, but nobody knew what it was. The story begins surprisingly early. Around 600 BC, a Greek philosopher named Thales noticed something unusual. If you rubbed a piece of amber with fur, it could attract small bits of dust and straw. The effect seemed almost magical, objects moving without being touched. Today we know this as static electricity, but at the time, nobody understood what was happening. In fact, the word electricity itself ultimately comes from the Greek word for amber. For centuries, that was about as far as human knowledge went. People knew certain materials behaved strangely, but nobody knew why, and nobody had found a practical use for it. Then, nature occasionally provided a much bigger clue: lightning. Imagine seeing a thunderstorm without any scientific understanding. A blinding flash appears in the sky, trees explode, animals die instantly, entire buildings catch fire. The power involved is almost unimaginable. Many ancient cultures viewed lightning as a weapon of the gods. And honestly, it is not difficult to understand why. Even today, a single lightning bolt can contain hundreds of millions of volts. For thousands of years, humanity could only watch. They had no way to control it, no way to study it, no way to harness it. Electricity remained a mystery. Then, something unexpected happened. People began discovering electric animals. One of the most famous examples was the electric eel. Ancient fishermen sometimes encountered fish capable of delivering powerful shocks. Roman physicians even used electric fish as primitive medical treatments for pain and headaches. Imagine that. Humans were using electricity medically nearly 2,000 years before they understood what electricity actually was. But understanding remained frustratingly out of reach. The breakthrough came during the scientific revolution. In the 1600s, European scientists began investigating electricity systematically. They rubbed materials together, recorded observations, built experiments, asked questions. For perhaps the first time, electricity became something people studied rather than simply witnessed. One important figure was William Gilbert, an English physician who carefully investigated magnetic and electrical phenomena. His work helped establish that electricity and magnetism were real, natural forces worthy of serious scientific investigation. But the biggest discoveries were still ahead. In the early 1700s, scientists began constructing simple electrical machines. These devices generated static electricity by spinning glass spheres and rubbing materials together. For the first time, humans could produce electricity whenever they wanted. Not much electricity, but enough to experiment with. People shocked one another for entertainment, created sparks, made hair stand on end. At first, electricity seemed more like a curiosity than a useful technology. Then came one of the most famous experiments in scientific history: Benjamin Franklin, the kite, and the storm. Popular stories often make it sound as though Franklin discovered electricity. That is not true. Electricity was already known. What Franklin helped demonstrate was that lightning and electricity were connected. During a thunderstorm, he flew a kite attached to a conductive wire. The experiment was extremely dangerous. In fact, similar experiments killed several researchers, but the results were revolutionary. Lightning was not supernatural. It was electrical. The sky and the laboratory were governed by the same laws. Suddenly, electricity seemed far less mysterious and far more important. Over the next century, discoveries accelerated. Scientists learned how electrical charges behaved, how electricity moved, how different materials conducted current. Then, in 1800, everything changed. An Italian scientist named Alessandro Volta invented the first true battery. This was a turning point. For the first time in history, humans could generate a continuous flow of electricity, not a brief spark, not a lightning strike. A steady electrical current. Electricity was no longer just an interesting phenomenon. It had become a controllable resource. And once that happened, progress exploded. Scientists across Europe rushed to experiment. One of them was Michael Faraday. Faraday made a discovery so important that modern civilization still depends on it. He found that moving magnets could generate electricity. This principle is called electromagnetic induction. It sounds simple, but it changed everything. Because it meant electricity could be produced mechanically. You did not need static electricity. You did not need batteries. You could generate power continuously, turn a wheel, spin a turbine, move a magnet, create electricity. Nearly every major power plant on Earth still operates using this basic principle. Coal plants, hydroelectric dams, nuclear reactors, wind turbines, different energy sources, same fundamental idea. And then came Thomas Edison, Nikola Tesla, George Westinghouse, names that became closely associated with the electrical age. By the late 1800s, inventors were racing to electrify the world. Electric lights replaced candles. Factories operated after sunset. Homes became brighter. Cities transformed. Entire industries appeared almost overnight. But there was one final challenge. Generating electricity is one thing. Delivering it is another. A power plant is useless if the electricity cannot travel long distances. This became known as the War of the Currents. Edison's direct current system worked, but only over relatively short distances. Tesla's alternating current system could travel much farther. The competition was fierce. Public demonstrations, business battles, propaganda campaigns. Some of the most dramatic technological rivalries in history. Eventually, alternating current won, and the modern electrical grid began taking shape. Power plants connected to cities, cities connected to homes, homes connected to appliances, and suddenly electricity became invisible. Not because it disappeared, but because it became ordinary. Today, billions of people use electricity without thinking about it. Flip a switch, press a button, plug in a device. The power simply arrives. Yet behind that convenience lies one of the greatest scientific achievements in human history. Because electricity was never truly invented. Lightning existed long before humans appeared. Static electricity existed before the first civilization. Electric fish were shocking predators millions of years ago. Humans did not create electricity. What we invented was understanding. We learned what electricity was, how it behaved, how to generate it, how to control it, and how to move it across entire continents. The modern world exists because of that understanding. Without electricity, there are no computers, no internet, no refrigeration, no satellites, no modern medicine, no global communication. Almost everything around you depends on a force that ancient humans could barely comprehend. A force that spent most of history hidden inside storms, magnets, and strange pieces of amber, waiting for someone to figure it out. And once we did, the world changed forever.